Okay. Hi, everyone. Good afternoon. I am Thalita Siqueira Sacramento, and I was a PhD student at Primatology Lab last year with Professor Júlio César Bicca-Marques as my advisor. So today I will present some results of our research that entitled Scrounging Marmosets Eat More When the Finder Share is Low Without Changing Their Searching Efforts. Generally, animals that live in groups end up searching for food together, a situation that brings different challenges than forage alone. Foragers may rely on social in addition to ecological information to locate feeding sites and choose between different foraging strategies. A number of social foraging models have been proposed based on game theory. One of them is a producer-scourger model, in which different individuals may behave as producer and spend time and energy using ecological information to actively search for food, or as scroungers and focus their foraging efforts on monitoring finders' behavior and scrounge part of the food they find. One factor that may influence the choice of foraging strategy is the finder share, defined as the proportion of the food resource consumed by the producer before the arrival of scroungers. A number of models predict that when the finder share is relatively small, the frequency of scrounging will be high because producing gives only a small benefit compared to playing scrounger. A model based on linear operator learning rule confirmed this prediction and further predicted that individuals would change their foraging strategy gradually in response to environmental changes. We tested these predictions in an experiment involving three groups of free-ranging black-tufted marmosets, Calitrix felicillata. We captured and marked all individuals. We manipulate the finder share at the artificial feeding stations by controlling the distribution of the food rewards, slice of banana, among the baited platforms. We divided our field experiments into two conditions: low finder share, few food rich patches, and high finder share, many food poor patches. We used Excel functions to randomize across sessions which platforms containing accessible food. We used two types of plastic box. The plastic box were either accessible with holes large enough to allow the marmosets to insert a hand and reach the bait, the slice of banana, and inaccessible with small holes that allowed the release of banana scent but did not allow the marmosets to have access to the food. In both cases, the holes were covered with brown cloth. Now we will watch a video from one section. So we recorded the number of times, the frequency that the focal individual played producer, that is, arrived at an unoccupied platform, and the number of times that it played scrounger, that is, arrived at a platform occupied by another marmoset. We recorded a new event when a marmoset re-encountered an unoccupied platform, or we scrounged an occupied one. We also recorded the number of visitors in which it ate using each forage strategy. In addition, we counted the number of banana slices that the focal individual consumed when it played producer and scrounger. We calculated the forage success separated for each strategy as the number of food items obtained by the focal forager through the use of one strategy divided by the cumulative frequency of use of that strategy at the end of a session. We calculate the mean value and the standard deviation of the forage success of all focals over the set of all sessions per condition. Everyone eat? Okay. As results and discussion, as expected, most marmosets had more success as a scrounger when the food was more concentrated and the finder share proportionally smaller. Therefore, the finder share influenced marmoset's success as a scrounger, even without a change in their frequent use of PS strategies. The marmosets tended to play producer more often than scrounger through the study. On average, just a minute, okay. Here, on average, for each platform visited as scroungers, under both experimental conditions, individuals inspected 3 platforms as producer. We suggest that this result could be influenced by the close proximity between all platforms in our experimental design, but did not impose distinct energy costs between producing and scrounging. We suggest that this result could be influenced by, individuals did not modify the frequency of the use of strategy and did not present a gradual learning. The frequency of use of the PS strategies was profitable in both conditions. We suggest that in social groups with high levels of tolerance and cooperation, such as those of marmosets, scrounger individuals can have higher forage success without increasing their searching effort by sharing productive food patches with producers and other scroungers. I would like to thank guys of Primatology Lab for our support, my advisor for the invitation, and everyone for your attention. Thank you. Bye-bye.